In this video, I'm going to demonstrate an application development tool called Oracle Application Express, or APEX. Using this tool, I'm going to build an application with a web browser user interface and an Oracle database backend in about 2 minutes. We'll start out in the application builder component and click Create. Create from spreadsheet. Upload file. Have the file name saved. And here's the data it uploaded from the file. It looked at the data, it made certain educated guesses. It said this column looks like a number, this one looks like a character, this one looks like a date. We could change those if we want. We have to give the table a name. We'll call it TestEmp. But we'll leave those assumptions in place for now. Here it's looking for a plural for reports. Here are the labels that it's going to use for various columns that it finds. We'll leave all those for now. Here it's looking for columns to use for reporting. We'll choose all. Here are numeric columns that it can use for statistical analysis, for making charts. TestEmp is the application name. We'll keep that. Pie chart looks good. And we're now ready, or we will be shortly. Oh, we need user interface theme, so we'll pick one of the pre-built themes. Now we're ready to create. And the application has been successfully created. About 2 minutes. Let's run it, see what it does. First we need to log in. Then we see 2 tabs here, TestEmps and Analyze. TestEmps is a listing of the employees. We'll click Analyze. We have reports and charts. How about a report by last name? There's our report. Go back to Analyze. We'll pick a chart by salary. And here's our pie chart. Then we'll go back to the employee page. And there's various built-in functions here. We could page through by clicking Next. We could sort by clicking the column header. Let's sort by last name. Now let's click this edit icon to edit the first row here. Let's change the salary, but let's test some error processing by entering some non-numeric characters there and attempt to apply the changes. Error message, salary must be number, which makes sense to me. So let's change it from 11,000 to 20,000. Now we'll click Apply Changes, and there's the new salary amount. Let's edit it again. Let's say we made a mistake and we really wanted to change it to 25,000. So there's 25,000, and before we click Apply Changes, let's ask ourselves, what would happen if another user decided to edit this row at the same time? Well, let's find out. We'll click File, New Tab, and here's our second user. Now the second user sees the 20,000 because that's what's in the database now. User 1 hasn't changed that new value yet. And user 2 is going to change commission percent from 0.3 to 0.4. So he's made that change, but he hasn't clicked Apply Changes yet. Now we'll go back to user 1. User 1 changed it to 25,000. He's ready to apply changes. And there's the new number of 25,000. Now, user 2 is now ready to apply his changes. He clicks Apply Changes. What do you think is going to happen? You got an error message. The error message is a bit technical. We could trap that error and clean it up for the users later. But for now, the essence of the error message is right here. current version of data in database has changed since user initiated update. So the application that Apex built has this functionality built in, lost update protection. If it were to allow user 2 to just write the 0.4 commission change, it would also write 20,000 because that's what's on user 2's screen. And that update that user 1 did from 20 to 25,000 would be lost. That's why it's called lost update protection. That's why it disallowed it. User 2 has to say OK to acknowledge the error, must cancel, and now the application will retrieve the employee data from the database again. This time it sees the 25,000 that user 2 updated. So now user 1 updated, so user 2 can go in, and now user 2 can make his change to 0.4 and apply changes. And now both of the changes are there, both the 25,000 and the 0.4. The reason Apex did this is because there can be interactions between the two columns, and it's much safer to prevent that update. Now, this is pretty sophisticated processing. This is processing that you wouldn't find in a lot of real-world applications that are out there. And this is important because problems that are caused by lost updates can be very difficult to diagnose because they're intermittent problems. They only occur if the two users are updating the same row at the same time. So it's an intermittent problem, which means it's very difficult to reproduce and difficult to fix and causes a lot of developer time. We got that for free with no programming. Now, of course, there's unique business logic that the application must develop. In this architecture, the business logic is going to be developed in PL/SQL, which is Oracle's stored program language. These programs are going to live in the database, and they're going to be executed by being attached to a user interface element. So in the application builder, the developer will say he wants a button, say, and will put in the name of the stored program that he's written to be executed when that button is clicked, and maybe data will be passed to it, or error processing will be done, and so forth. The point of this architecture is that all this UI processing is done without programming. So you're removing a whole chunk of programming from the development process, and you're also putting the business logic directly into the database where it can run more efficiently, it can take advantage of the efficiencies and the scalability that Oracle has developed over the past 30 years, and it will remove the Java or C# processing entirely from the applications. No Java, it's web-based development with no Java or C# in the middle tier, no middle tier. So anytime you have fewer pieces, you're going to have a machine that's easier to fix and it's going to be more reliable. And that's what these applications are.